Hey guys, this is Miss Nichols. What I thought we would do today is review a little bit for your quiz that's going to be tomorrow. Um, so this little review sheet is going to be posted right underneath this video in the modules. You'll be able to find a link to click on it if you want to print it out. You can print it out. If you would rather just do it on notebook paper, that's fine also. Whichever works for you works for me. So what I did was I put this worksheet on Smart Notebooks so that I could write on it and go over some of it with you. So what I wanted to do was let's look at numbers 1 through 7. So these are pretty much the easiest of the review problems, and those will be the easiest kind of questions on your quiz. So if you look at numbers 1 through 4, those are having you rewrite. They have you go from one form to the other. So just bear in mind on, for example, numbers 1 and 2, if you want to take a log and write it in exponential form, if you have something like log base 2 of 8 equals 3, if you want to rewrite that, the base of the logarithm is 2, so the base of the exponent is 2. The logarithm always equals an exponent, so since this equals 3, our exponent is 3. 3, there we go, good enough. And it will equal 8. So that's rewriting it. So 2 cubed equals 8 is a true statement also, so that's another way you can check your work. Just be mindful on number 2. Remember, natural log is base e. So when you rewrite number 2, it's going to be, the base will be e. Okay. Then numbers 3 and 4 have you go backwards the opposite way. So for example, if I had something like, let's see, 4 squared equals 16, and I wanted to write that as a logarithm, well, I would write log, and then the base of my logarithm is going to be the base of the exponential problem, so that would be base 4. And a log always equals an exponent. So I'm going to leave some space and then put an equal sign, and then it's going to equal 2. So then in the blank that I left, that space, is going to go the number 16. It's the number we hadn't used yet. So if you type in log base 4 of 16 in your calculator, you should get 2. That's a way you can check your work. Um, Now numbers 5 through 7, those you can do in your calculator. Remember, you can do Math Alpha Math. That's a shortcut for you to get a logarithm where a base is able to be typed. So you just type it in your calculator. That's it. So the easy as that, and you get the answer. Remember, if it says there's an error, then it would be something that's undefined or something you could say no solution, whichever. Now, as we scroll down, 8 through 11, that's when it gets just a little more complicated. That's when we are going to be expanding expressions and or well, 8 through 11 would be just expanding. So on the next slide, let me just review these properties because you're going to also use them for the condensing section, which is after this. So let's review those expanding properties. So remember, if you have the log of a b, it is the same thing as the log of a plus the log of b. So whenever you see multiplication happening in a logarithm, you can expand it by adding both logarithms. If you have the log of a divided by b, you can expand that by subtraction. So it's going to be log of a minus log of b. And then the last one is if you've got a logarithm and you've got something raised to a power, that rule says that you can put the power out front. And so it's n times the log of a. So those are the rules that you're going to be using on the next two sections, expanding and condensing. So let's go back down to it. So if we looked at, for example, let's just do number 9. Okay, there's a lot of multiplication going on there. In fact, there's 3 things being multiplied together. There's an x to the 1/2 power, there's a y to the third power and a z to the 4/7 power. So I can expand that with, instead of multiplying three things, I can do three different natural logs and I'm adding them together. So this would become the natural log of x to the 1/2 power plus the natural log of y cubed plus the natural log of z to the 4/7 power. And then after you do that, you're going to go ahead and use the power rule, which says take those powers and put them out front. So the 1/2 is going to go in front of natural log x. And then the 3 is going to go in front of the natural log of y. And then the 4/7 is going to go in front of the natural log of z. And that is your fully expanded problem. Just be careful on number 10. The square root right here is the same thing as 4 times x to the 1/2 power. Remember we talked about in the class, and that we talked about that in class, that the square root of x is the same thing as x to the 1/2 power. So just be careful on number 10. Number 11, you have a lot of multiplication going on and you have division. So on number 11, just be aware that, well, heck, let's just do it. Okay. So you're going to get, first of all, I would take this in steps. I know a lot of you don't like to do that, but I would take this in steps. So the first thing I would do is I would subtract that, that division. So I broke up the numerator and the denominator with subtraction. And then in the numerator, you're multiplying 3 and y to the 6th power. So this right here, I can expand that with addition. So this is going to turn into the natural log of 3 plus the natural log of y to the 6th power. And then minus, so here you have 5x. So what I would do, guys, is I would also expand that with addition. But I'm expanding two different things. So I'm going to use parentheses because I'm going to subtract both of these. So it's going to be natural log of 5 plus the natural log of x. So what I meant by subtracting both of them, you're subtracting natural log of 5. That's what this applies to. And you're subtracting natural log of x. That's why I put it in parentheses. So then the last thing I would do is I would fix the power on the natural log of y to the 6th power. So bring down the natural log of 3, bring down the 6, natural log y, and then minus, and then you just keep all the rest of it the same. Natural log of 5 plus the natural log of x. And then there you go. So that is condensing. Sorry, that is expanding. So now let's do condensing. Okay, so if you want to look at these, let's look at, I don't know, let's look at number 13. Okay, on number 13, let's see here. Okay, we want to work backwards. So the first thing that we're going to do is we're going to take care of any exponents because that's the last thing we do when we expand. So it's going to be the first thing we do when we condense. So these numbers out front, this 4 right here and this 2 right here, we need to turn those back into exponents. So this is going to be log of 4 to the 4th power, and then plus log of y squared. And so, first of all, we got 4 to the 4th power. So what I would do is, since you can actually figure out what 4 to the 4th power is, I would just figure out what that is, and it's 256. So this is log of 256 plus the log of y squared. And then lastly, if two logs are being added, you can condense them with multiplication. So I'm going to write a single logarithm. And remember, you're condensing with multiplication. So you're going to multiply 256 and y squared. It's not going to be adding 256 and y squared. You're multiplying to condense. So it would be 256 y squared, and that's the answer. Just be careful on number 12. This minus sign right here means you're going to do division. And then on 15, I get a lot of questions about this right here, okay, the two minuses. It doesn't mean that there's a fraction in a fraction. I get a lot of people say, oh, it's going to be x plus 7 on top, and then x cubed on bottom, and then y squared on bottom. No, we're not doing fractions and fractions. So if that just blew your mind, don't worry about it. Okay, but if we have two minus signs, it just means that both the 3 log x and the 2 log y are both going to be in the denominator, and they're both going to be multiplied together. So the 3 log x and the 2 log y, they both go in the denominator, and you're going to multiply them together. But first, before I did anything, I would take care of the exponents, the 3 and the 2 out front. And same thing with the 1/2. I would take care of that first. Okay, so now let's go to the back or the second page. So now we are looking at solving exponential equations. This is one of the last things we did before all the craziness started. So let's just, for example, I don't know, we could look at, this is normally where I would ask you guys which ones you want me to do. But if I don't go over one of them and you need help, guys, always email me. I will help you as best I can, I promise. So I don't know, let's look at 18. 18 is one of those problems where you can get it to have the same base. So I am going to actually just go ahead and use a full page because I don't want to cram my writing in. So 49, I'm just going to rewrite it. 49 to the x power equals, and then it was 7 to the 3x plus 5. Yes, 7 to the 3x plus 5 power. Okay, so you can get these 49 to be base 7 by making 49, turning it into 7 squared. And I'm just going to rewrite the other one because it's already in base 7. And so then we've just got to multiply our exponents together, and that's going to be 7 to the 2x power equals 7 to the 3x plus 5 power. So now that we have bases that are the same, we can set the exponents equal to each other. So we're going to do 2x equals 3x plus 5. So then you're going to subtract 3x from both sides. And then you get negative x equals 5. And then divide by negative 1. And you get x equals negative 5. And there's your answer. So that would be, what number was that? That was number 18 on the worksheet. Let's see here. Let's look at 17. Now 17, first of all, what you're going to have to do is you're going to have to get rid of this plus 3. So let me just rewrite the whole problem to begin with so I don't have to squish my writing. So I might have to go back and forth to look at it a lot because I've probably already forgotten what the problem was. It was negative 4 times e to 2x power plus 3, and I think it was negative 5, but let's check. Yep, negative 5. Okay, so first I need to get this 3 to go away because I want to get the base by itself, and the base of this problem is e. Not negative 4e, it's just e. So we've got to get e all by itself. So the first thing I would do is subtract 3 from both sides. And when that happens, you get negative 4 e to the 2x power equals, and then negative 5 minus 3 is negative 8. And then, guys, I told you the base is e. We want to get that by itself. So negative 4, we need to get rid of that by dividing. What you do to one side, you do to the other. You get e to the 2x power equals positive 2. So now that, excuse me, my goodness, I still haven't gotten over this cold. Okay, but I'm getting there. All right, guys, so now that we've got the base by itself, this is when you want to take a logarithm. We can't get these to have the same base like I did in the previous problem, so that's when logarithms come in. Now, the base of this is base e, so we're going to take log base e of both sides. Log base e. But in class, guys, I told you that log base e has a special fancy name. It goes by natural log. So instead of writing log base e, I can just write ln, or natural log. So I'm going to take the natural log of the left side, and I'm going to take the natural log of the right side. What you do to one side, you have to do to the other. So now we're going to apply our exponent rule that says that this little 2x right here has to go in the front. So this becomes 2x, and then natural log e equals, and then natural log of 2, you can go ahead and figure that out in your calculator. So the natural log of 2, I'm looking at my calculator, it is 0.693 if I rounded 3 decimal places. So now looking at what we have written down, this right here is going to cancel out. If you want to type it in your calculator and see, the natural log of e does equal 1. So that cancels out. So all you're left with now is you're left with 2x equals 0.693. And now we're going to get x by itself by dividing by 2. So if I take 0.693 and divide it by 2, I get 0.3465. If you want to round that to 0.347, that's fine. I just went ahead and did all 4 decimals because it gave me exactly 4 decimals. So that would be how you do number 17. Number 19, I guess we could do that one together. I don't want to do them all together because then you guys won't have a lot of practice. But maybe you could listen to me do it and then try to do it yourself without my guidance. But first of all, 19, you're going to have to get that 4 by itself. So it's 8 to the x minus 3 power. Plus 4 equals 35. Okay, so we've got to get this 4 to go away. I'm not sure if I said we need to get 4 by itself earlier. If I said that, that is not what I meant. We need to get rid of it. We need to get the base, which is 8 by itself. So what we're going to have to do is we're going to have to subtract 4 from both sides first. So subtract 4. When you do that, you get 8 to the x minus 3 power equals 31. Now, if I could get these to have the same base, that would be awesome. But I can't raise a number to a power and get 8 and take that same base and raise it to a power and get 31. It's not possible. I'm referring to how we did this problem right here with the 49 and the 7. We could make those both base 7. But on this one, we cannot make them both have the same base. So that's when you have to take a logarithm. So the base of this problem is 8. So we're going to take log base 8 of both sides. I'm going to write log base 8, and then 8 to the x minus 3 power equals log base 8, and then of 31. So we're going to do the exponent rule that says we're going to take the x minus 3 and throw it in front. So I've got x minus 3 times log base 8 of 8 equals, and then log base 8 of 31, you can type that in your calculator. So math alpha math in the calculator, log base 8 of 31, and I got 1.651. Okay, so now looking at what we have, log base 8 of 8 cancels out. It is 1. So whenever something equals 1 and you're multiplying like we are in this case, it just cancels out. So all we have left is x minus 3 equals 1.651. And now the only thing we have to do is add 3 to both sides. And you get x equals 4.651. And there's your answer. Okay, so now going to the bottom part of this, these are the logarithmic equations. These are what we did yesterday. So let's look at number 20. Number 20 is the easiest case. It's when you have a log on one side and a log on the other, and they're both the same base. When that's the case, all you're going to do is you're going to set the insides equal to each other. And then you're going to solve for x. So guys, this would be an algebra 1 concept, so don't get lost in the algebra 1 stuff. So subtract 2x, and you get 3x. And then add 9, and you're going to get 16. And then divide by 3. And if you divide by 3, you get 16 thirds, which is the same thing as 5.3 repeating. Now, the only thing about these problems is you have to make sure that you don't have an extraneous solution. So when you have logarithmic equations, meaning equations with the word log in them, you need to always double check your answer. If you plug it back in, let's see here, if you plug it in and back here, you plug in 5.3 repeating, 2 times 5.3 repeating plus 7 is definitely going to be a positive number. If you plug it in back here, 5 times 5.3 repeating minus 9 is still a positive number, so you're good to go. So 5.3 repeating or 16 over 3, whichever you prefer, is your final answer. Okay. On number 21, these are a little bit different because you've got to get the logarithm by itself, and you don't have a log on both sides. So when you only have one logarithm, you need to get it by itself. So the first thing I would do is I would subtract the 7 from both sides. And then you get 2 times log x equals 14, and then divide by 2. Get rid of that 2, and you get 7. So now we've got the logarithm by itself. So once you get this, now it's just a matter of rewriting it. So you're going to rewrite it in exponential form. So if I've got log of x equals 7, remember the base is 10 if it's not shown. So this is going to be 10 to the 7th power equals x. That is how we rewrite that logarithm into something exponential. And then you just figure out what 10 to the 7th power is. And it's a big number. It's a 1 with 7 zeros. There's your answer. Okay, 22 and 23, I don't know, I guess of the two, I think 23 is probably, and it's not probably, 23 is definitely the hardest one. So let's go ahead and let's do this. But before we do 23, guys, I just want to remind you on 22, since you have both of these log base 3, you're going to want to condense these with multiplication. So my first clue to you would be to do log base 3, and then you've got x times x minus 2, and that equals 1. And then go ahead and distribute that x. That'd be x squared minus 2x equals 1. And then go from there. Rewrite it in exponential form. So your base is 3, and then your exponent is 1, and it equals x squared minus 2x. Because it's quadratic, get it set equal to 0, crisscross, and then check your answers. Okay, 23. Holy moly. Okay, so first of all, on 23, I see that subtraction has happened. And if subtraction has happened and I want to condense these two to a single logarithm, I need to go ahead and write it as a division problem. So log base 2, and then the numerator is x plus 4, and the denominator is x minus 17 equals 3. So now I have a single logarithm, so I can go ahead and rewrite this into exponential form. Okay, so the base is 2, the exponent is 3, and then we have x plus 4 over x minus 17. And then I would figure out, well, what's 2 cubed? Well, 2 cubed is 8. And you have 8 equals x plus 4 over x minus 17. So at this point, what I would do is, we got to get a LCD. This goes back to a couple chapters ago. Actually, I think it was this last chapter. So to solve this, you got to get an LCD. Yuck. Okay, so the LCD, they're not all this nasty, just so you know. The LCD is going to be x minus 17. So you're going to multiply both sides of the equation by x minus 17. Okay, so these x minus 17s cancel out. That's the nice part. And then here you got to distribute your 8. So this is going to be 8x. Well, it doesn't really look like much of an x. My handwriting on this thing is terrible. So thank you guys for just bearing with me. All right, so 8x minus, and then 17 times 8 is 136. And now you just have an algebra 1 kind of equation to solve. So first subtract x from both sides, and you get 7x minus 136 equals 4. And then I would add 136 to both sides. 7x equals 140. And then lastly, divide by 7, and you get x equals 20. Now again, go back and double check your answer. If you go back and you plug in 20, all the way back up here to the top, if you plug in 20 right here, you're going to get 24, which is a positive number. If you plug in 20 here, you're going to get 3, which is also a positive answer. So you're good to go. So your answer for that problem after all that work is x equals 20. Okay, so what I want you guys to do is I want you to do the evens. This is your assignment. I want you to do the evens on a piece of notebook paper, or you can print this out under the assignment. And then I want you to do the evens and then upload it, and that will be your daily grade for today. And then we've got a quiz tomorrow over this stuff. I will also post the answers to this review sheet later on, so you can check your work. And then other than that, have a happy St. Patrick's Day. Look out for leprechauns and for pots of gold at the end of the rainbow. Um, I just had to add that. Sorry, it's corny, but you guys know me by now. So anyways, have a good rest of your day. Bye, guys.